My name is Chunsheng Yan from Zhejiang University. It's the overview of my presentation. Please, next. Yeah, it's our newly established Asian Book Museum within Zhejiang University. Next. Here is reading room, library, and next. Yeah, is a real book library. We have a paper, Chinese handmade paper library, which contains about 200 different varieties of Chinese handmade paper, which is our primary source of experimental handmade paper samples. Next, please. Yeah, Chinese handmade paper is a fundamental elements of China's paper cultural heritage, which plays a vital role in the preservation and restoration of ancient Chinese books, calligraphy, and paintings. Next page. There is abundance of raw materials for crafting handmade paper, including bark, bamboo, grass, and so on. Please, next one. We employed 5 different varieties of bark-based handmade paper samples and 2 types of bamboo-based handmade paper samples. Each of these categories has been further subdivided based on their respective sources. In total, our study encompassed 18 distinct types of handmade paper samples. Next one, please. This is a micrography of one handmade paper. It evident that it is rich in fibers. The principal chemical component of these fibers are cellulose and lignin. Next one, please. Cellulose is a complex macromolecular polysaccharide structure composed of diglycopyranosyl groups linked by glycosidic bonds, creating chain-like molecule structures. Next one, please. Next one, yeah. Lignin is a complex organic polymer characterized by a three-dimensional network structures formed through the interconnection of 3 phenylpropane units. It was highlighting that lignin is rich in aromatic rings structures, and these rings are primarily responsible for the fluorescence peaks evident in the detect Raman spectrum. Sorry, okay. This table, can you the form? Okay, just this. This table displays the Raman spectral assignments for cellulose and lignins. Next one, please. In this study, we employed 4 distinct spectral bonds. Bond 1 corresponds to pyrene, ring, torsional, and flexural vibrations. Bond 2 is associated with glycosidic bonds, asymmetry and symmetry vibrations. Bond 3 signifies the position of the lignin-induced fluorescence. And bond 4 is related to various carbon-hydrogen stretching vibrations. Next page. Thank you. Various data pre-processing techniques can significantly enhance the accuracy of machine learning models. Next one. Yeah, thank you. In our study, we employed 7 data pre-processing methods, including data normalization, baseline correction using R+. And the next one page. The fourth method is data pre-processing method. Is defined as this equation. For 2 vectors with length of n, 2 vectors x, y, less than of n, CCM expands the spectral data dimensionality from 1 times n to 1 times 2n minus 1. Next page. Thank you. The fourth method is 2-dimensional synchronous correlation method, 2D SM. Is defined as this equation. The 2D SM is performed by conducting tensor products of the rows between rows within each category of measured Raman spectral data matrix M. It was highlighted that the 2-dimension SCM is quite different from the traditional Raman correlation spectroscopy techniques. Next page, please. The fifth method is 2-dimensional asynchronous correlation method, 2D ACM. Is described in the above equation. The 2D ACM is realized by conducting the tensor product of one row and the other Hilbert transform of the other row within the same category of measured Raman spectral matrix M. The Hilbert transform is defined as the convolution of the input signal M and the response signal 1 pi t is a short response, which is effectively functioning as a all-passed 90-degree phase shift. Next page. Next page, please. I cannot see the upper part of the PPT. Yeah. The sixth method is 3-dimensional synchronous correlation method, 3D SM. Is defined as this equation. The 3D SM is performed by computing the tensor product between a row of the 2D SCM spectral matrix Y and 1D spectral matrix M. Next page, please. The last data processing method is 3-dimensional asynchronous correlation method, 3D ACM. The 3D ACM is implemented by calculating the tensor product between Hilbert transform of a row from 2D ACM and 2D ACM spectral matrix H prime and a row from 1D spectral matrix M as described in this equation. From this table, it's evident that as the dimensionality of the measured spectral data increases, the equivalent frequency points, the number of equivalent equivalent samples within each category, and the number of equivalent total samples also increases. This expansion is in equivalent frequency points and equivalent sample numbers. Is a key factor contributing to significantly enhancement of accuracy of machine learning models. In this study, we employed 6 machine learning models for the analysis. The first one is principal component analysis, PCA. Next one, combined with linear regression, LR. Next page, thank you. The second machine learning model is partial least square method, PRS, combined with linear regression. And the third one is the support vector machine, SVM, combined with linear regression, LR. Next one. And the fourth method is the K nearest neighbor, KN. And the fifth method is random forest, RF. And the last machine learning models is convolutional neural network, CN. The first 5 methods is implemented using the R programming language. And the last one is implemented using the Python language. Here is our results for the classification and identification of Chinese handmade papers using Raman spectroscopy combined with machine learning models and data processing. In this figure, the horizontal axis represents data sets for the RD for the with RD for raw data, BRD for baseline removed data, CCM for cross-correlation data, TD-SCS for data processed using 2D ACM, 2D SCM, and TD-SCI. The last one is for data processed using 2D ACM. The vertical X corresponds to the accuracy of machine learning models defined as the required the R squared values. Regarding the impact of the 3-dimensional SCM and 3-dimensional ACM, please refer to the results presented in these figures. It evident that the R-squared values of for the PCA-LR machine learning models are all close to 1. It was highlighting that the R-squared values for the PRS, LR, KN, RF, and CNN machine learning models approach or equal to 1. This is the confusion matrix. The confusion matrix is a valuable tool for evaluating the classification and identification of materials classification and identification. Within this figure, the matrix rows and columns correspond to actual and predicted classes, and the diagonal elements corresponds to accurate prediction, and alpha diagonal elements is represents the incorrect prediction. It's predicted from one class as another. This outcome closely mirrors the trends observed in the previous illustration. This is the conclusion. And next. This is our publications for the presentation. The last one is under review. Okay, so thank you for your time and attention.